What do you think are the uses of materials like graphene?
Graphene is when one thinks to a nanomaterial, thinks to graphene. I think it is the most famous two-dimensional material. It is based on carbon, which is one of the most common elements. I know that based also on my experience that graphene is tried to be used and applied everywhere in very different topics. For example, the energy storage, the bio-related fields, the sensors and catalysis and so on. Graphene, thanks to its beautiful, we can say, physical, mechanical, electrical properties, both as a material itself and as a platform for other materials. For example, in the field of the energy storage, for example, batteries, supercapacitors, and so on, graphene and other nanocarbons like carbon nanotubes, carbon nanofibers, and so on, are widely used, at least at the research level, as agents that could improve the performance of an electrode, and so the performance of a whole battery or a supercapacitor. So, but not only, for example, also in the sensor field, graphene-based sensors, at least at the research level, I talk about the research level, graphene-based sensors offer advantages in terms of other materials. The use of graphene also in a wider commercial scale could be affordable in the next years.
Graphene is talked about for many years, so why don't we find graphene like in an everyday life outside of research?
Yes, it's known as 2004, something, 2002, something like this. The most important problem is that, that graphene must be produced and synthesized in a controlled way to achieve and to obtain its, we can say, exceptional properties. And obviously, if a technique requires a high degree of control, these techniques also requires a lot of cost, typically. So this is why graphene is not so common in real and practical applications, because there exist some alternatives to graphene which are not so exceptional, but maybe are cheaper, concerning the production of graphene especially.
Yes, I also think it's a matter of cost. Like, as you say, there are alternatives that we can already use, and the technologies to produce them are already known, and they have existed at the industrial level for some time. And so make like research and introduce new equipment to produce graphene and so on, it will require too much cost. And like, okay, it could give exceptional properties to the component that we're talking about. I don't know, but is it a valid alternative to what we have right now? Could be, but maybe we need to decrease the cost for the graphene production, like find a different way or a more cheap way to do it.
A clear example of the thing that is a lot talked about, but then doesn't see a strong, robust application. And this is, as my colleague said, due to production, storage, and these kind of issues. Because to make the long story short, graphene is made of a layer of carbon atoms. So you basically start from graphite. Graphite is the material that you find in your pencil, for example. Of course, you have to treat it in a particular chemical way. And from graphite, that is made of many layers of carbon atoms. You should exfoliate these layers to obtain one single layer. Extraordinary properties of graphene are usually lost when the layers become more than 10, let's say. But we should say more than 5 to be precise. And so, since it is very difficult to obtain so few layers, then the production cost and the control of the quality requires many costs. So this is why it is not so widespread.
What would be the advantages of a carbon nanotube over graphene?
They are different materials, so they are not necessarily an alternative one to the other. They can collaborate, for example, because graphene can be seen as a sheet of paper, while nanotubes are like tubes. So nanotubes are especially interesting for their mechanical properties that they show along the z-axis. So along their length, let's say. They can be involved in the same applications, but for maybe different reasons. So they have their pros and cons, one with respect to the other.
What could be the applications of a nanowire?
Nanowires are one-dimensional chains of atoms. If we stay at the atomic level, so if we have a wire which is made only by one atom, if we have a chain that is formed by one atom aligned with another atom, in this case, the application, I don't see a real application since such structures are extremely unstable. I think, for example, to carbon atomic wires, which are a chain of carbon atoms. If we talk about wires, so generic one-dimensional structures, in this case we can have many applications in different fields. For example, speak again about the energy conversion, the solar cells, reinforcement of composites. For example, if we add one-dimensional structures, or if these structures are, for example, aligned in a material, they can make a sort of reinforcement to the material. But also, for example, application in coatings for different purposes, so surface treatment, restoration, and so on. So I think that the application of nanowire obviously depends on the material that composes the nanowire, since we can have nanowires made of different materials which are specific to different applications.